Okay, we're going to go a little over time since we're not in the classroom, so I'm just going to finish this out. So one little part left. So if just kind of to wrap up the discussion, we're going to take a look at the second derivative test. So if your f prime of c is 0, and if your f double prime exists on an interval containing c, now we say that if f double prime is positive, then f of c is a relative minimum. If f double prime is negative, then f of c is a relative maximum. If f double prime is 0, then the test fails, and in such cases you can use the first derivative test to determine whether f of c is a relative max or a relative min or neither. Okay. Okay, let's just take a look at this example 4. This is the last example, this is the last of it, and we're going to finish out here. So example 4 says find the relative extrema of this function. Let's take a look at something. Okay. So with example 4. So now we're given f of x. Where'd it go? Is negative 3x to the 5th plus 5x cubed. So if we look at f prime of x, this is going to be a negative 8x to the 4th plus 15x squared. Okay, so for our second derivative test, we say let f prime of c be 0. So let's set this as 0 and see what are our critical numbers. Again, we're not going to have anything that makes it undefined. This is a polynomial. So if we set this to 0, we get, let's see. Okay. So we have this negative 8x to the 4th plus 15x squared equals 0. Notice we can factor out, we can do more. Oh, 5 times 3, there we go. Made a mistake. It's like I knew something wasn't looking right. Here. 5 times 3 is 15, I think I added. So, let's see, 5 times 3 is 15. Is it 15? Yeah, there we go. 5 times 3, 5 times 3. Okay. So we can factor out a 15x squared from each of these terms. So if we have 15x squared, here we're left with a negative x squared, 15x squared, so it should be plus 1 equals to 0. Okay, and this is 15x squared times 1 minus x squared equal to 0. Notice this is actually a difference of two squares, so you can rewrite this as 15x squared times 1 minus x times 1 plus x. So this tells you when x is 0, and x is 1, and x is negative 1, it'll make the function 0. Okay, so what we're going to do now is test these points in our second derivative and see what it gives us. Again, so we have our f prime of 0, or f prime of c is 0, and then let f double prime exist containing the c. So now if this f double prime of c is positive, then it's a relative minimum. If it's negative, it's a relative maximum. And if it's 0, then the test fails. So if we look at the point when x is a negative 1. So the sign of our f double prime, let me see, I think we need our f double prime. So our f double prime is going to be a negative 60 x cubed plus 30x. So now if you test f double prime of this point, let me see. So I'll go here. F double prime of negative 1 is going to be a negative 60 times a negative 1 cubed plus 30 times a negative 1. That's going to be, this is going to be a negative 1 times a negative 60, which is a positive 60, minus 30, which is going to be 30. So f double prime of negative 1 is going to be positive. So our conclusion at this point when x is negative 1, we have a relative minimum. So when x is 0, our f double prime of 0 is going to be a negative 60 times 0 cubed plus 30 times 0, which is going to be 0. So our f double prime of 0 is 0. So here we have that the test fails. The second derivative test fails. And then when x is 1, f double prime of 1 is going to be negative 60 times 1 cubed plus 30 times 1, which is going to be a negative 30. So here we have the f double prime of 1 is negative. So here we have a relative maximum. Okay? Not necessarily a table, but sorry about that. Okay, so that's just a quick example showing the second derivative test. I think I went about 10 minutes over, but that's okay. You're not in class, so give a little, take a little. We'll continue this discussion when we meet next Wednesday. I'm going to post homework for this section 3.3 on WebAssign. And have a good weekend.